Hi class, in this video we're going to talk about Chapter 6, how to test, debug, and deploy an application. So a lot of this material is stuff that you have evolved into your knowledge bases already, but this way we'll kind of confirm it all. First of all, you've been working all semester at testing and debugging your Java applications, but I'd like to show you how you can also trace the execution of a statement through even the system code that comes from Java. We're going to use NetBeans to set breakpoints and step through our code. We've done that a little bit in some of the videos. And then discuss how we could use an executable jar file to deploy an application. Now, there is a difference between testing and debugging. We want to talk about the different types of errors, look at stepping through our code with NetBeans, and describe some advantages and disadvantages of different ways to deploy applications. Here is our future value application from the textbook. If you remember this application, we type in an investment amount and how many years we're going to keep this investment and an interest rate, and we get an investment return. I think we called it a certificate of deposit calculator in one of our assignments, but it's basically the same thing. It tells us, based on our monthly investment and other input data, what the future value of that investment is. So we've got a problem with this one. So we'd like to find the logic error. That's always the goal of our testing, is identifying any sort of problems before something is put into production, meaning before other people are using it. It's so much easier to fix problems if we're the only people that are using it. But sometimes we have to have others find things for us, and that's one of the goals of some formalized testing. So we want to make sure that we debug and fix all of those errors before we put anything into production. So testing is finding the errors, debugging is fixing the errors in our code. So we really have three test phases. We are going to check our interface, our prompts to our user, and our responses to our user. We're going to test the application with valid input data and make sure the results are correct. And then we're going to test the application with invalid or unexpected user actions and try to do anything we can think of to make the application fail. So we have multiple different types of errors that can occur. You've seen that. First of all, syntax errors are those errors that keep our program from compiling. So if somebody says, a syntax error caused my program to cancel when it was running, that would be incorrect because a program could not be compiled to run if it had a syntax error. So when we get the message from NetBeans that we have an error and it says, would you like to run the last good compile, we always want to say no, because we want to be running a current version of our code. So if we have a syntax error, we need to fix it. Next, runtime errors are those kinds of errors that don't violate syntax rules, so everything compiles fine, but some sort of exception or error condition is encountered when the program is executing. Logic errors are statements that don't cause syntax or runtime errors, but can produce the wrong results. So in the future value application shown, the future value isn't correct. So we're dealing with a logic error. It did not cause the program to cancel with a runtime error or an exception, and it did not keep the program from compiling with a syntax error. So something is wrong with the logic. So here's some code that contains some syntax errors. So you were missing semicolons, and this one doesn't say int or double or whatever, or missing a closing parenthesis here on this if statement. Here we have a method name starting with an uppercase letter. So all of these are examples of syntax errors. We've seen a lot of those, and I know you've had a lot of experience working on them. You see misspelling keywords. That's a common syntax error. Forgetting to declare your data type. Missing a parenthesis or a bracket. Now we know that a curly brace problem can cause a lot more errors, so that one little syntax problem can generate a ton of different syntax errors, making the compiler so confused. If we forget a semicolon, we usually get a pretty good message to that effect. And forgetting an opening or closing quotation mark can cause some unpredictable results sometimes. Now we also can have problems when we mistype a name or an identifier of a variable. So we might name an identifier using camel case, where we have lowercase and uppercase first letters of every word, and then another time we use that same variable name, we forget to do the uppercase on our first word for camel case, and then that variable is not the same. So it's not that it doesn't recognize it as the same, it's that it's not the same. It's not the same variable, it's a different variable name. So we get the incorrect results. So we have to be careful that we always name things and use the same exact identifier every time we refer to a given variable or method. We also have to be careful about using reserved words, global properties or global methods, other things that we can't use in our code as identifiers. Whenever we're running our code, we can have problems in interpreting how things are executing. Maybe we didn't check to make sure that a value is actually a double before we try to read it into a double variable. So that can cause us a runtime error. We could accidentally use one equal sign instead of two in an if statement when we're testing numeric or Boolean values for equalities. That could cause us some inconsistent results and potentially a runtime error. We could accidentally use two equal signs instead of the equals or equals ignore case methods to test two strings for equality, and that could lead to a runtime error or inconsistent results. Whenever we use floating point numbers like doubles, we have to remember that we can have arithmetic errors like this one, where we end up with this never-ending floating point number, and we can use our big decimal class to avoid those kinds of problems. We can insert println statements in our code to figure out where things are going wrong. So to do debugging, we can trace our own execution by adding our own debugging code. So in this example, we are looking at the calculate method, and we've added a print statement to say started in the calculate future value method, and then we are outputting the monthly investment amount and the interest rate and the number of months. Then we're going to use our for loop to calculate that future value and then output the future value when we're done and return. So this printing will give us some good debugging output so we can see where things are going wrong. So in this way, we are using our own println statements to trace our execution to debug any problems that we have. Here's the data that's printed out to the console. We can see what's happening with each month. Now, another way that we can do some debugging and see what's going on is by using the debugger in our IDE. And of course, we're using NetBeans as our IDE, so we can look at NetBeans debugger, but most IDEs include some sort of online debugger, and they're super helpful. And what we can do is set a breakpoint, and a breakpoint is a place where we want our execution to stop momentarily.